Hello friends, today's question. A point mass M is suspended at the end of massless wire of length L, cross-sectional area A. If Y is the Young's modulus of elasticity of the material of the wire, obtain the expression for the frequency of simple harmonic motion along the vertical line. Okay, so we have to find out the frequency of the oscillation for this wire, which is having a mass suspended to one of its end. So first of all, we are going to find out what will be the force due to stretching of the wire. Force due to stretching. So in the question itself, it's given that the mass M is suspended to the one of the end of the wire. So because of this mass, the wire gets little bit elongated. Okay, so we can say the wire undergoes elongation when mass M is displaced vertically. So if the displacement is small, that is delta L, so we can use, you can say, restoring force F will be equal to minus K of delta L. Therefore we can say for small displacement, delta L, the restoring force F will be equal to minus K multiplied by delta L. Let us call this equation number 1. Now we can use also the formula for Young's modulus of elasticity, and our Young's modulus Y is equal to stress oblique strain, and stress is equal to our force oblique area. Stress is equal to F upon A, and strain is equal to change in length divided by original length. So we substitute these formulas in the equation Y. So we get Y is equal to F upon A divided by delta L upon L, or we can write this as FL A into delta L. So from here we can find out value of F, force. F will be equal to by A delta L upon L. This is equation number 2. So comparing equations 1 and 2, comparing equation 1 and 2, we get K delta L is equal to Y A delta L upon L, and delta L cancels out. So from here we can write that the value of K, which is our spring constant, K is equal to YA upon L, and the frequency for a SHM is given as omega, which is equal to K upon M and its square root. You can write that frequency of SHM omega is equal to square root of K divided by M, and where omega is our angular frequency, and M is the mass attached to the wire, or we can call this a spring also, and K is our spring constant. K is spring constant. So we are going to substitute value of K in this equation, and so therefore we can write that omega is equal to square root of K was our YA upon L divided by M, and the frequency F is equal to omega upon 2 pi. So substituting value of omega, we get 1 upon 2 pi square root of, this will be equal to YA upon LM. So this is our frequency of SHM along vertical line. This is the frequency of SHM along vertical line. This completes the question. Thank you.